the sum of series 1, then minus 3x, 5x square, minus 7x cube, and so on till infinity. And one condition is also given that mod of x is less than 1. That means x is lying from minus 1 to 1. They have given us 4 options here. Okay, first let's try to find out what the series is, right? So first number is 1. Okay, then I have 3, 5, 7. Oh, this is a series which we know, right? What is it? Correct, AP. So we have an AP with us. Similarly, in this question, if I see the terms like minus x, then x square, then minus x cube, these terms are coming in which sequence? Well, this is a GP. That's right. So I have an AP and a GP multiplied together. And what is AP and GP multiplied together, guys? AGP, right? So this sequence is basically an AGP. Now, we have to find some of this AGP till infinite terms. What is the first thing we should think about? Yes, what is the common ratio of GP, right? Because that has to be known. So here we already know the common ratio of GP is minus x with us. How do you solve an AGP then? Well, we multiply by the common ratio, shift the terms and subtract, isn't it? So let's do that. I'm multiplying here by the common ratio, that is minus x, and shifting the terms. So this one will come here and it will become minus x, right? Similarly, this minus 3x will come here and it will become plus 3x square. Minus 5x cube will come the next term, and so on. This will go till infinity. Now what? Well, now we'll subtract equation 1 and 2. So when I subtract equation 1 and 2, on left hand side, I'll get 1 plus x multiplied by s infinity, right? While on the right hand side, I'll get first term 1 will come as it is, isn't it? While the next term will be minus 3x plus x, that will become minus 2x. What about the third term? Minus 3x square and 5x square. When I combine these two, I'll get plus 2x square. The next term will be again minus 2x cube, and so on. It will go again till infinity. How to find the sum of these terms now? Well, if we look here, minus 2x plus 2x square and so on, all these terms till infinity. What is this sequence, guys? You are right. This is a GP here. And what is the first term of this GP? Well, minus 2x is the first term, right? And what about the common ratio? Well, the common ratio is minus x. So I have a GP with me whose first term and common ratio is known. Now what? Well, now I have to apply the formula for infinite GP. I hope you remember the formula. So let me write this down first. We already recovered that 1 plus x into s infinity is equal to 1 minus 2x plus 2x square minus 2x cube till infinity. This we got a GP. We know A and R. The values are with us. Now what is the formula for infinite GP? Yes, that is A upon 1 minus R. That's correct. So I have this formula. Let's apply this. So when I apply, I'll get 1 plus x multiplied by s infinity is equal to 1 is going to come as it is. For this GP, this part, I have A value as minus 2x divided by 1 minus, the common ratio is minus x itself. So this is what I got. So when I simplify or when I take the LCM, this will become 1 minus x divided by 1 plus x. So now I have got the value of s infinity. So s infinity finally comes out as 1 minus x divided by 1 plus x whole square. And if we see the options here, we can say that C will be the right answer. Have you understood? Very well. So in this question, what they have asked, the sum of series 1 into 2 plus 2 into 2 square plus 3 into 2 cube till 100 into 2 raised to 100. Okay, they have given me 4 options also here. So first, to find summation of this series, I have to identify the series, right? So what the series is about? If I see the first term, I have 1 and 2. That means it's multiplication of 2 different terms. Similarly, the second term has 2 and then 2 square. Third term has 3 multiplied by 2 cube. Similarly, the last term is 100 multiplied by 2 raised to 100. Okay, so I have multiplication of two different kind of terms. 1, 2, 3. These terms. What this sequence is, guys. 1, 2, 3, 4, and so on. That's correct. That's an AP, right? Similarly, what about this part? 2, 2 square, 2 cube, and so on. That is the GP. So I have an AP multiplied by a GP. AP multiplied by a GP is what? Well, it's an AGP. So I have AGP with me. How to find sum of AGP? Well, to get AGP sum, what I need to find first is common ratio of GP. And what is the common ratio? Well, it's 2. So the common ratio of GP is 2 with me. To find the summation, let me consider this summation as S. So I have S is equal to 1 into 2 plus 2 into 2 square plus 3 into 2 cube till 100 into 2 raised to 100. Right? This is what I have. Okay, now what? How do you get the summation of AGP? Well, we multiply by common ratio of GP and then what? Then we shift the terms to right and subtract, isn't it? So we'll do the same thing here. I'm multiplying this by 2 here. So this will become 2s. Now the first term, that is 1 into 2, will become 1 into 2 square. This I have to write here because I'm shifting the terms. So this is my first term, that is 1 into 2 square. Okay. Similarly, what about the second? Second is 2 into 2 square. When I multiply this by 2, it will become 2 into 2 cube. Right? It will be written here below the third term of the above sequence. Are you getting it? Okay. Continuing further, below 100 into 2 raised to 100, what I have to write here? The term which was previous to it. So what is the term which is just before 100 into 2 raised to 100? Well, that will be 99 into 2 raised to 99. Isn't it? So I have 99 into 2 raised to 99. When that is multiplied by 2, what we will get here? We'll get 99 into 2 raised to 100. Right? Okay. And what about the last term? Well, when I multiply 100 into 2 raised to 100 by 2, it will become 100 multiplied by 2 raised to 101. Okay, so I have my 2s also with me. Now what? Now subtract. So let's subtract. What we'll have? This will be minus s here. 1 into 2 will basically be equal to 2. Right? So this is my first term. When I subtract 2 into 2 square and 1 into 2 square, I'll have 2 square. So my second term will become 2 square. Similarly, you can say the third term will be equal to 2 cube till 100 into 2 raised to 100 minus 99 into 2 raised to 100. That is equal to what? When I subtract this, it will become 2 raised to 100. Okay, so now I have these terms and the last term is also there. 100 into 2 raised to 101. Don't forget to write the last term. So now I have some sequence minus the last term, that is 100 into 2 raised to 101. Now to find the summation, I have to recognize the sequence. What is this sequence basically? Well, that's a GP. You are right. So I have a GP with me and I also have the first term. What is the first term of this GP? Well, 2. Isn't it? 2 is the first term of this GP here. And what about the common ratio? I have 2, 2 square, 2 cube. What is the common ratio? R is equal to 2. And what about the number of terms? Because I have to find the number of terms also. So it is from 2 raised to 1 till 2 raised to 100. So I have 100 terms with me. So I have number of terms. I have my GP first term as well as the common ratio. Now what? Now we have to recall what is the formula for sum of n terms of GP. What is that? Do you remember? The formula was A multiplied by 1 minus r raised to n upon 1 minus r. Or you can reciprocate it and write as A multiplied by r raised to n minus 1 upon r minus 1. Right? So we have this formula with us. So when we substitute the values, let's see what we get. We'll get minus s is equal to A is 2 multiplied by r. The common ratio value is 2 again. raised to number of terms is 100 minus 1 upon 2 minus 1. This is my GP summation formula or GP summation value minus the last term. What the last term is? It's 100 into 2 raised to 101. So this term will come as it is, and I can write here this will become minus 100 into 2 raised to 101. Okay, now I have got the value of minus s. Now what? Well, let's multiply by minus sign. We'll get the value of s, isn't it? So let's write this minus s first. We got minus s is equal to twice of 2 raised to 100 minus 1 minus 100 into 2 raised to 101. This is what we got. Is this much clear? Very well. Let's multiply this by minus sign. So when I multiply this by minus sign, it will become s is equal to 100 into 2 raised to 101 minus 2 multiplied by 2 raised to 100 minus 1. Let's open up the brackets. This will become 100 into 2 raised to 101 minus this 2 multiplied by 2 raised to 100 will be what? Well, that is 2 raised to 101. So I have 2 raised to 101 with me here and plus 2. So this is what the value is. Further, when you want to simplify, it will become 99 into 2 raised to 101 plus 2. This will be the value of s. And if we see the options, we can say B is the right answer. Have you understood? Very well. Well, in here they have asked the value of summation I is equal to 1 to infinity 2i minus 1 divided by 2 raised to I plus 1. Okay. So for this summation, first I have to figure out what the sequence is. So let's substitute the values of I. I'm taking the summation as s. When I put I is equal to 1, my first term is 1 by 2 square. Right? When I put I is equal to 2, my second term will become 3 by 2 cube. Then when I put I as 3, my third term will become 5 by 2 raised to 4, and this will go on till infinity. Now I guess you can figure out the sequence. Well, how we'll do that? 1, 3, 5, 7 and so on. These terms are in AP, that's correct. And the reciprocal part, 1 by 2 square, 1 by 2 cube, 1 by 2 raised to 4 is an, well, that is a GP. So I can say that when AP and GP are multiplied together, we get a AGP. So I have a AGP with me. Okay, so let's try to find the summation of this. How do you find the summation of AGP? This is my sequence. 1 by 2 square plus 3 by 2 cube plus 5 by 2 raised to 4 till infinity. We have already figured out this is a AGP. And to find sum of AGP, we have to multiply by what? Well, the common ratio of GP. That's correct. What is the common ratio here? 1 by 2. So we are going to multiply this entire sequence by 1 by 2, shift the terms and subtract, isn't it? So this will become s by 2. The first term will come over here and this will become 1 by 2 cube, right? When I multiply this by 1 by 2, this is my first term plus. Similarly, my second term will come here. This will become 3 by 2 raised to 4 and this will go on till infinity. Now what? Let's subtract. So when I subtract, this will become s by 2 is equal to, first term is as it is, that is 1 by 2 square. So this will become 1 by 2 square plus, when I subtract these two parts, 3 by 2 cube and 1 by 2 cube, what do I get? Well, it is 2 by 2 cube. So I have the next term with me, that is 2 by 2 cube. Similarly, for the third term, when you subtract, you can see that it will come out as 2 by 2 raised to 4. And so on, this will go till infinity. Okay, so now how can I find the summation of this sequence? Well, if we keep aside the first term, that is 1 by 2 square, these terms 2 by 2 cube, 2 by 2 raised to 4, next term will be 2 by 2 raised to 5. All these terms are in GP, right? Infinite GP. What is A here? Well, we have A as 2 by 2 cube, or I can write that value as 1 by 2 square, right? Similarly, what the common ratio is? Well, that value is equal to 1 by 2. This is very easy to figure out. Now we have to recall what was the formula for infinite terms of GP. Do you guys remember? Well, the formula was A upon 1 minus R. This is the formula, right? Now we have to apply this. So what we got? We got S by 2 as 1 by 2 square plus a GP which had A as 1 by 2 square and R as 1 by 2. Isn't it? So let's apply the formula and substitute the values. So the GP summation will become 1 by 2 square divided by 1 minus 1 by 2. So S by 2 value will come out as 1 by 4 plus 1 by 4 whole divided by 1 by 2. That will be S by 2 is equal to 1 by 4 plus 1 by 2. Now we have to just solve the value. And finally, S comes out as 3 by 2. We have got the answer. So what the sequence came out as? AGP. And we know how to solve AGP. We find the common ratio of GP, multiply the sequence by that, shift and subtract. And then we get a GP. Easy, right? Well, in this question, what they have asked us sum of 50 terms of the series, that is 1 plus 2 multiplied by 1 plus 1 by 50, 3 multiplied by 1 plus 1 by 50 square and so on. So to find this, I have to figure out the sequence, right? If we see the terms actually, first term is 1, second term is multiplication of 2 and 1 plus 1 by 50. Third term is multiplication of 3 and 1 plus 1 by 50 square. So this 1, 2, 3 is which sequence? That's correct. It's an AP. Similarly, 1 plus 1 by 50, 1 plus 1 by 50 square. Next, it will have 1 plus 1 by 50 cube is a GP. So I have AP multiplied by GP. What is that sequence, guys? That's an AGP. That is correct. So we have AGP with us and we have to find summation of that till 50 terms. So now what? Now first I have to find the common ratio of the GP part. Well, that is 1 plus 1 by 50. I don't want to write that. So I'm assuming that part as X. So X is the common ratio. Now first we have to figure out the 50th term of this AGP. Okay, so if we have AP here, that is 1, 2, 3 and so on, I can say the 50th term will be what? Well, that is counting numbers till 50. So I have my 50th term as 50 for AP. Similarly, for GP, I have my first term as 1. Then I have X, then I have X square and so on. So what will be the 50th term for this? Well, what is the formula for general term of GP? Well, that is A multiplied by R raised to n minus 1. So for 50th term, it will be 1 multiplied by X raised to 49. So I have my 50th term of AGP. That will be 50 multiplied by X raised to 49. Clear? Okay, so now I have my AGP, I have my 50th term also. So let's start the sequence. S will be equal to 1 plus 2x plus 3x square till 50x raised to 49. This is my AGP. Now what? How do we solve AGP? Well, we multiply the AGP by common ratio of GP. And what is the common ratio? X. So let's multiply by X, but you have to remember, we have to shift the terms. That's correct. So this is S multiplied by X. I am shifting the terms. 1 multiplied by X will become X over here. Similarly, 2X multiplied by X will become 2X square. So the second term here is 2X square and so on. Below 50X raised to 49, what should I write? For that, I have to figure out what is the term which was before this part, that is 50x raised to 49. So what is that term? Well, before 50 for AP, I'll have 49, right? Similarly, for GP, before x raised to 49, what will I have? X raised to 48, that's correct. So this term is 49 into x raised to 48. Now, when I multiply this part by x, what will I get? Well, it will become 49x raised to 49. isn't it? Okay, and what about this last term? So when I shift this last term to right, this will become 50 multiplied by x raised to 50. So this is what we get when we multiply by x. Now what? Now we'll subtract. So when I subtract this will become s multiplied by 1 minus x on the left hand side, while on right hand side the first term will be 1, which is coming as it is. What is 2x minus x, guys? This part. Well, 2x minus x is x, isn't it? So this part is x with us. Similarly, 3x square minus 2x square will become x square, and so on it will go. What is this 49 x raised to 49 and 50x raised to 49 difference coming out as? Well, it is x raised to 49. So I have this with me, and the last term is also there, that is minus 50x raised to 50. Okay, so now I have this. So I have to find summation of this entire part. For that, what is this part actually? Well, this is a, you are right, this is a GP. So I have a GP with me, and what is A value here? Well, A is 1 and common ratio is x. So what is the formula for n terms of GP? Do you guys remember? It is A multiplied by r raised to n minus 1 upon r minus 1. I know you do remember. So this is our formula. We have A with us, we have r with us. What are the number of terms? Well, we are going from x raised to 0 here till x raised to 49. From 0 to 49, how many numbers are there? 50, that's correct. So that means n value is 50. So I have GP, I have A, R and number of terms. So let's put in the formula. So what will I get? Well, I'll get S multiplied by 1 minus X is equal to, A is 1. This will become X raised to 50 minus 1 upon X minus 1 minus the last term. The last term is 50 multiplied by X raised to 50. Is this part clear? Very well. So now I have this. Now what? Now I guess we can substitute the value of x, right? And let's find out what the sequence answer is coming out as. So we have this much. S multiplied by 1 minus x is equal to x raised to 50 minus 1 upon x minus 1 minus 50 into x raised to 50. This is what we have just obtained. Clear till this step? Very well. We also know that x value was 1 plus 1 by 50. So now, what is the value of 1 minus x? Well, I can say that this summation multiplied by 1 minus x will be equal to minus 1 by 50. Isn't it? Okay. On the right hand side, don't substitute the value of x here in x raised to 50. That will be a very large term, right? So we'll leave that as x raised to 50 only. So this will become x raised to 50 minus 1 upon. Now what is x minus 1? If I have my x as 1 plus 1 by 50, x minus 1 will be what? You are right, it's 1 by 50. So I have this value as 1 by 50 minus, this is 50 multiplied by x raised to 50. Now what? Well, let's take LCM on the right hand side part. So this is minus 1 by 50 multiplied by s on left hand side is equal to 50 multiplied by x raised to 50 minus 1 minus 50 multiplied by x raised to 50. Wow. Can you see what we have got? Well, the terms are cancelling out here. Which two terms? X raised to 50 multiplied by 50 is cancelling out, isn't it? So we have got a very short answer. That means what the answer will be, for that we'll see the terms left. So we have s multiplied by minus 1 by 50 is equal to minus 50. This is what was left, right? Let's just cross multiply. S value will come out as 2500, which will give me option A as the right answer. Have you understood? Well, what they have given in this question, sum of the series 1 plus 2 multiplied by r 3 multiplied by r square, 4 multiplied by r cube, and so on till infinity. The value is given to me as 9 by 4, and they have asked what is the value of r. Okay, so what is the sequence, guys? 1, 2, 3, 4 is an AP, that's correct. And what about this r square, r cube? Well, that is GP. And if AP and GP are multiplied together, the sequence comes out as AGP. That's correct. So I have AGP with me. I have GP common ratio as R, which the value I have to find out. So let's take this S as 1 plus 2r plus 3r squared till infinity, right? I have the value of S as 9 by 4 with me, which I'm going to substitute in the end to find the value of R. Let's multiply by R because that is how we solve AGP. We multiply by the common ratio of GP and shift the terms and subtract. So when I multiply by R, this will become my first term, that is 1, will get multiplied by R and it will become R. So I'm writing it here. Clear? Similarly, the next term 2r will get multiplied by r. So it will become 2r square, right? Similarly, 3r square will become 3r cube and so on. The terms will go on till infinity. Is this much clear? Okay. Now what? Well, now we'll just subtract. So when I subtract these two equations, I'll have S multiplied by 1 minus R is equal to, first term will be 1 itself, 2R minus R. What that is? Well, that is R, right? So I have my second term as R. Third term, that is 3R square minus 2R square. What that is? Well, that is R square. So this value is R square and so on. It will go till infinity. So I have a sequence here. Yes, what is the sequence? 1, R, R square, R cube and so on till infinity is a, right, that is a GP. And if this is a GP whose first term is 1 and the common ratio is R, what is the formula for infinite GP summation? Do you remember? I hope you do. What is the value? A upon 1 minus R. That's correct. So I have the formula with me. That is A upon 1 minus R. So when I substitute, I'll get S multiplied by 1 minus R is equal to A. That is 1 divided by 1 minus R. Is this clear? Okay. So from here we got S multiplied by 1 minus R is equal to 1 upon 1 minus R. So the value of S will come as 1 minus 1 by R whole square. Right? And this value is given to me as 9 by 4 in the question. So when I equate this to 9 by 4, I'll get 1 minus r square value as 4 by 9. I've just taken the reciprocal. Right? Now I can say that 1 minus r will be equal to plus minus 2 by 3. Is this clear? So am I getting one value or two value from here? Well, we'll get two. One with plus, another with minus. So let's find out the values first. So our value will come out as 1 by 3 and 5 by 3. This we can calculate. Once we'll take plus, another time we'll take minus. But, which value of r can we take? Well, is there a condition on infinite summation of GP? Yes, what is the condition? The common ratio should be between minus 1 to 1, right? So, which of the values between minus 1 to 1? Only 1 by 3. That means the answer will be R is equal to 1 by 3 and we have to reject 5 by 3. And if we check the options, we can say option B will be the right answer.